Hey guys, it's Mr. Haas here, and today we're going to talk a little bit about pressure systems. Now, you learned in the last part of this module about air pressure, and we're going to review that a little bit, and then move into what that has to do with weather. So today we're going to talk about air pressure and pressure systems. So when we look at our guiding questions, we want to know, how does convection create weather? Hint, hint, we're going to talk about that today. Convection from our matter and energy unit plays a big role in pressure and wind. And we want to know what type of weather is associated with high and low pressure systems. So here's a real life scenario. OCL is getting ready to go on a field trip. So he watches the Weather Channel to see the weather, so he'll know how to dress. The weatherman says that an area of high pressure is setting up over Monroe today. He wonders, how is this going to help him dress for the field trip? So I want you to take a minute and just talk with whoever's there with you, or yourself if you're the only one, about what you think. And it's okay if you don't know. All right, welcome back, guys. So what we're going to continue to talk about is air pressure. And based on our real life scenario, I'm guessing a lot of you don't know a lot about air pressure. So here we go. We learned in the last part of this module that air pressure is the weight of air. And if you imagine a column of air, or imagine you were in a tube that was just touching your shoulders and you just fit in it, and then that tube extended all the way to space, like in this picture, if we weighed all the air from you up into the edge of space, that would be what air pressure is. We would measure the weight of all that air, and that's air pressure. So we would call that 1 atmospheric pressure. When you're like if you were at the beach doing it, that'd be exactly 1 atmospheric of pressure. Now, we don't feel that pressure because we're used to it. Just like if you're driving in the car and your parents are going to constant speed, you don't feel the movement of the car. However, if they speed up or slow down, you do. Well, the same thing is true about air pressure. You don't feel it when it's constant because you're used to it. But if the air pressure gets more or less, you do feel it. Like if you go up in an airplane, or if you were to go down a mountain or up a mountain, you'll your ears, that little pop in your ears, that's your body detecting a change in air pressure. So air pressure, we basically know, is the force that air is exerting by its weight. And the demonstration I did with the can in the earlier part of this module showed how that if I lower the pressure inside the can, the air on the outside rushes to that. And you know that if you have a basketball and you put a hole in it, the air rushes out because we put higher pressure inside the ball because we fill it up so we can bounce it. But if I put a hole, air always wants to go from high pressure to areas of lower pressure, which in the case of the can, crushed the can. So one thing I want to talk about is how we measure air pressure. We measure them using a barometer. And I know we talked about this for just a few minutes before the end of school, before we went out, and I had a barometer up in my classroom. But basically, these little instruments, depending on which one you're looking at, the left or right, they're both barometers, but there's little mechanisms in them. There's little things that when the air pressure changes, it changes the dial, or in the one on the right, the amount of mercury, and it gives us an indication of a change in pressure. Now, a change in pressure is really important. So that's what I want to talk to you about now. So when we think about a change in pressure, okay, I also want to go back to what we've talked about earlier in the year with convection. When we have cold air, okay, cold air, we know that when things are cooler, they condense, which means there's more air molecules in a given amount of area than if there was warm air. So if you look at the pictures on here, these are both the same size square. But notice the cold air has a lot more molecules in that square than the warm air does, which means the cold air weighs more. And when something weighs more, it sinks into the other things that don't weigh as much. So when we measure air pressure, we measure that at ground level. So if I had a barometer measuring air pressure and the air was colder, it would sink, which means more air is coming down and pushing on that barometer. And we would say we have high pressure because there's a high amount of it in there. It doesn't mean the air is going high. It just means there's a high amount of air, a heavy weight pushing on us. Whereas if we have warmer air, That warmer air has expanded. There's less molecules. It's lighter, and that warmer air is going to float up. And that's why we get convection. We didn't get into that when we talked about convection, but that is why liquids and gases convect. The warm air rises because it's lighter. There's less molecules in it because it's expanding. So now that we understand that, let's talk about when we get these air pressures outside in our atmosphere and what that does, okay? So if you take a look on the left, okay, we have cold air. And if you follow those little diagrams, you'll see that the cold air is sinking, which means if you are standing down here where the H is, you would feel high pressure because the air is heavy. So that high pressure, that cold air sinks, there's more of it pushing down. Now, you don't usually feel it, but your barometers are sensitive enough to detect that change in pressure. Now, if you look, since the air is sinking, all the water vapor in the air isn't going up. And if water vapor isn't going up, well, then you're not going to have condensation or clouds. So that's why usually with high pressure, we have sunny, nice days. And I like to think of high and happy sunny days, okay? High pressure, happy days. Now notice the H is blue. That's because the air is cooler. It doesn't mean the air is cold. You can have high pressure and still have an 80-degree day, okay? Just compared to the air around it, it's cooler. Now, if you have a low pressure system, that's the one on the right, that's the L. Notice that is a red L because it is warmer. So that warm air rises. And because the low pressure is causing warm air to rise, it's taking all that water vapor with it. And that water vapor goes up into the atmosphere, condenses, and we get a lot more clouds, a lot more rain, possibly storms. So that is the difference between your high pressure and your low pressure. Okay, low I like to think of as lousy. A low pressure, lousy day. It's going to rain, unless you like rain. But usually you can't do it in your outside plans if it's raining. So your low pressure is your lousy day, and it's because it is a warmer day, warmer air. Okay, so remember those colors. Those are important. And here's another way to look at it. Okay, as the air sinks, it actually spins. Okay, and you get that high pressure, and then that high pressure will flow to the area of low pressure, and then it will flow upwards and create your clouds and your storm. All right, so little sneak peek here. If you were to stand in between these two pressure systems and you were right here, terrible stick person, I know, and that was you. Oh my goodness, we're going to pretend that's you. You would feel air moving across the surface of the earth from high to low. And that is where wind comes from. So when you guys feel wind, that's what it is. It's air just moving from an area of higher pressure to an area of lower pressure. All right, so this is important because if we take a look at this map, we will see, this is an actual weather map, we will see that there's different H's and L's around the map. So I want you to take a second, and you'll also see A, B, C, D. And I want you to think about these four cities. And I would like you to tell me, based on the weather symbol that is closest to them, I want you to tell me what the weather might be like in that city. I'll give you just a minute. Go ahead and pause this so you can talk about it. And then when you come back, I'll give you the answers. All right, now that you're back, let's talk about this. We can see that near city A, there's a big H, which means there's a high pressure system. And high pressure, again, means cooler air sinking, which means there's not a lot of clouds forming because that water vapor is not going up in the atmosphere. And that is also true about city C. So for A and C, you're going to have a cooler day, but it's going to be nice and sunny. Whereas if you're on city B or D, since it's near low pressure, you're going to have warmer temperatures, more humidity, and a better chance of clouds, rain, and or storms. So that's why these are important. And here's another example of that. You have your high and you have your lows. And you notice the clouds and all the rain and everything is up where this low is. But this high pressure is actually keeping it relatively clear in this area. And that is why high pressure and low pressure and pressure systems play a big part in our weather. All right. So we go back to OCL. And he wants to know how to dress for the day because there's high pressure. Well, he should dress, if it's in the summertime, he should probably dress pretty nicely. Maybe put some suntan lotion on because it's going to be a sunny day and not much of a chance of precipitation. All right, I hope this helps. And now go answer some of those questions about high pressure and low pressure, and view the video on wind because we're going to connect wind in the next video. Thanks, guys.